So everyone.
Thank you. Yeah, these are not my slides, so let's wait a second. Yeah, they're coming. Yeah, perfect. Okay, let's see if... So I think the clicker is not... Oh, yeah, okay, it is now. Okay, so I cannot go back. Okay, it's pretty slow. Okay, hi everyone. This is my presentation called Bitcoin Development Made Easy. I'm Alekos Filini, that's my Twitter handle. And I'm going to start very briefly by talking about who I am. So why am I here talking about BDK? I'm originally the founder of BDK, which is called, BDK is a shorthand for Bitcoin Development Kit. I created the project kind of as an hobby project in 2019. In 2020, I managed to get some funding to work on it. And over time, the team grew to like 5, 6 people. And I managed that team until around 2023. Now I'm not involved on the code anymore. So if you have very deep technical questions about the code, probably not the right person to answer them. But I'm still involved in the project as a board member of the BDK Foundation, which is the entity that basically collects donations and spends them on the development. So pays developers working on BDK itself. I'm currently working at this company called 22. We make Bitcoin hardware devices, and we use BDK as well. So it was, I transitioned from a purely open source project into a commercial project using the library I created. And before all that, so even before BDK, I was at Blockstream. I work on Jade and the Green Wallet, and that's, I think, where a lot of the inspiration for BDK came from. So working on wallets, real-world production wallets, kind of made me realize that we needed something like BDK. And I'm going to start by kind of explaining why BDK exists. So I'm going to quote Massimo Banzi. I mean, this is not really a quote, but a few weeks ago, I was at one of his open lectures he did in Italy. Massimo Banzi is the co-founder, one of the creators of Arduino. And his presentation was about democratizing innovation. And the way I interpreted his presentation was basically these two things. So first of all, it's very important to have very accessible tools so that anybody can play and get creative with those tools and invent things. And when you do that, so when you open up tools to everybody, people are going to create stuff with them. Most of those things are going to suck, but 1 in 1,000 is going to be good. And not only that, people building shitty projects, they're still going to learn a lot and over time, improve their skills and build better projects. And I think this is kind of a clear way of describing what I always had in mind working on BDK, which is we need to make Bitcoin development, especially in this case layer 1 Bitcoin development, very, very accessible so that people can quickly prototype, invent new things on Bitcoin and make use of Bitcoin so that we can effectively improve the ecosystem for everybody. And why? So BDK is a layer 1 library. BDK is an on-chain library. Why layer 1? You may think, we're moving to eCash, we're moving to Lightning. Why do we need a layer 1 library? And the answer is that layer 1 is still the king. So first of all, nowadays, many, many people still transact on layer 1, still send each other payments on-chain. But even if that were to slow down, I would say, ultimately any layer 2, any protocol needs to go on-chain. So we will still need tools to build those on-chain transactions, to monitor the chain, to spend on-chain funds. And the problem is layer 1 is easy on paper. Theoretically, it's much easier than Lightning because it's not like a complex multi-party protocol. But the truth is that there are a lot of tricky details that are very hard to get right. and if you screw up, you're going to lose people funds. So you're either going to create maybe an unspendable address, or you're going to, I don't know, create invalid transactions. And why Bitcoin is tricky, I would say for a few reasons. First of all, the fact that it's layers and layers of retrocompatible hacks, which we call soft forks. But effectively what they are is we cannot change fundamentally Bitcoin because otherwise it's not a soft fork anymore. So we just take existing fields, existing bits of a transaction and kind of repurpose them, reinterpret them in a bunch of different ways. So just to give you some examples, there's a field called nSequence in every input in a transaction, and this field used to have a specific meaning, which was ordering multiple transactions spending the same input, but over time it was completely repurposed to other things. So for example, now we use the nSequence to signal for RBF or to enable relative time locks, so the check sequence verify. So it's like a lot of those layers and layers of weird hacks that are not very intuitive at all. So unless you really study Bitcoin very deeply, it's very hard to get those right. Also, there's a bunch of weird, I would say, consensus quirks. So one example is the op check multisig, which needs like a dummy push to the stack. This was a bug in Satoshi's code, but it became consensus, so now we have to stick with it. And it's also an adversarial environment, so you have to be really careful with what you do, because you could end up creating, I don't know, addresses that are spendable by anybody if you're not careful. At the same time, Bitcoin is also very, very powerful, and I have a feeling that we're not really using it to the fullest power, because we have signatures, we have hashes, we have time locks. We can combine those arbitrarily. We can construct very complex scripts. With Taproot, it gets even pretty efficient to have multiple different scripts in the same address. We also have SIGHASH flags, so we can sign a single input, sign all the inputs, but only one output. We can do lots of really cool things. And all of this together, so Bitcoin is tricky. Bitcoin is very powerful but unused. How do we solve that? How do we make it accessible and powerful? And my answer is with a universal Bitcoin SDK, which is BitcoinDevKit, BDK. So what BDK tries to do is a very generalized library, which means you can do a single sig, or you can do a multi-sig, or you can do weird, decaying time locks. You can create a script where on day one you need, 3 signatures to spend from it, but then if you leave the funds there for a couple of years, maybe you only need 2 out of the 3 keys to sign. So if you lose one key, you just have to wait a little bit and you can still recover your funds. And this mostly comes from descriptors. So we use descriptors kind of natively in the library. And descriptors allow you to express those complex spending conditions with like a text, human-readable language. It's also interoperable thanks to PSBTs, because BDK is just one component, but BDK needs to interact with other wallets, other components. So for example, if you make multi-sigs wallets, you may want to use one device to sign the transaction and then move the transaction over to another device, which is going to add its own signature. So it needs to be very interoperable, and PSBTs provides that. So the PSBT standard provides that. On top of it, I think now we can say it's safe, it's written in a safe language, and it's battle tested. So it's been used in a bunch of pretty big projects. Recently, Proton Wallet announced their, or rather I should say Proton Mail announced their wallet, which is called Proton Wallet, and it's built on BDK. The core library is written in Rust, so it's again like a very safe language, very solid language. And then on top of it, we have language bindings, so you can still use it, even if it's in Rust, you can still use it from like Android, iOS, and a bunch of other languages. And also, one of the core concepts of BDK is to make it very modular, so you don't necessarily need all of it. So if you take all of it, you have like a full-blown Bitcoin wallet. So you can create transactions, you can monitor the chain, you can see when you've received a transaction. So when there's a payment being sent to one of your addresses, you can now spend this payment, you can sign transaction, you can do all that, but you don't necessarily need to use it all. So there are a bunch of projects that just take some parts of it. So for example, I think Liana is using just the coin selection that was implemented in BDK, and then they have their own logic for everything else. I want to spend a minute talking about Rust. So why is BDK written in Rust? And the answer is that it's a very, very safe and very performant language because it compiles down to like a native binary. So this basically lets us port the code very easily across many, many different platforms. So you can run BDK on desktop and mobile, obviously, but you can also run it in a browser if you compile it down to WebAssembly, or you can even run it on embedded hardware. So I mentioned before, at 22, we make Bitcoin hardware devices, specifically an hardware wallet, and we run BDK on the hardware wallet. So we run BDK on the small embedded core. And it's also pretty easy to wrap with bindings. So currently BDK offers Kotlin, Java bindings, Swift, React Native, Flutter. So all the major, I would say, all the mobile frameworks pretty much are covered. And on top of it, we also have Python, C, and JavaScript with varying level of completeness. So most of the focus is on mobile platforms because that's where most of our customers, most of our users are, while we still support some desktop platforms as well, like Python, C, and JavaScript. Or you can also like fully write it in Rust and compile it to, for example, WebAssembly if you want to run it in the browser. So talk is cheap, show me the code. This is just, I don't know, 2 random snippets of code I took from the documentation. First example is how to create a transaction. And you can see that you can do like pretty advanced things. So you can say, I want to create a transaction builder. I want to send to this address this amount of sats at this specific fee rate. Do not spend change, for example, means, in a wallet you have some addresses which are called external addresses, which is where you receive funds from external entities. And then you have internal addresses, which are the addresses that the wallet itself generates to receive its own change. You can say, I don't want to spend the change for whatever reason, and I want to enable RBF. So this is like 4 or 5 lines of code. Internally, what this is going to do is it's going to take all the UTXOs in your wallet, do the coin selection, add the inputs, add the outputs, at the correct fee rate, create the change, all that for you. And the second example, this is a bit more involved maybe, but this is how you would sync your wallet with an Electrum server. So there's a bunch of other code which is not shown here, which saves the result, so saves the response. But this is basically saying, I have this wallet, I have these script hub keys, so these SPKs. I want to sync up with this Electrum server for all of these script hub keys, and this is going to generate all the relevant requests, send them over, get a response, and then with this response you can update your internal state. So you can apply that to your internal state of your wallet. So now you know about incoming transactions, you know about UTXOs, etc. Yeah, so this is basically it. I wanted to leave some time for questions, but if you're a developer, you want to get started, these are the 3, I would say, major places you should look at. First one is our website. You should definitely check out the BDK CLI section, especially at the end. We have what we call the BDK CLI playground, which is like, it's a CLI, so a command line tool, but compiled for WebAssembly. So you basically run the command line within the browser, so you don't need to install it locally or anything. You just, from the browser, you can play with the BDK command line, which is kind of the main example for BDK. We have a Discord chat, Discord server, pretty active, very big community there, helping each other out. And finally, if you want to contribute to the code, this is our GitHub. So that's where you find the main repository, so BDK itself, the bindings, and everything else around it. Yeah, so if there are any questions, I'm happy to answer them. Otherwise, thank you for coming here. Yeah, so no questions. Thank you.